So welcome everyone. Thank you for joining us in the first the webinar series on space sustainability. As you all know, space sustainability is not just a buzzword or a buzz concept. It has become critical for reliable space applications here on Earth. As you are aware, reliable access to space and secure space operations ensure that we are able to derive the benefits and the applications with which we use satellites for here on Earth. If you check the African space policy, it says that Africa commits itself to responsible use of outer space. In other words, Africa has committed itself to promoting different mechanisms, norms, practices that will promote space sustainability. Of course, Africa is going to benefit, and the entire world system is going to benefit by so doing. So that's actually the essence of this webinar series. And if you may recall also, last year, the theme of the World Space Week, which is, officially adopted by the UN, was on space sustainability. So we just thought, let's have a series of discussion on space sustainability and begin to explore the different aspects of space sustainability. And today we are starting off the series with a discussion on use of lasers in space, or you may say peaceful use of lasers in space. And our facilitator is somebody who is an expert in this field, who has actually also advised the UN on things relating to lasers in space. That's Petr Bohacek. You would have seen his bio when we were registering for the webinar, so I won't go through his bio here in order for us to save time. But before he comes up, before I hand over to him to begin, I just want to say a few words about the ASLI. So a brief on African Space Leadership Institute. I mentioned the African Space Policy and Strategy a short while ago. There are two main policy goals in that document, and that is that to create a well-coordinated and integrated African space program that is responsive to the social, economic, political, and environmental needs of the continent, as well as being globally responsive, and also to develop a regulatory framework that supports an African space program and ensure that Africa is a responsible and peaceful user of outer space. And that's the basis of what I said earlier, that Africa is committed to being a responsible and peaceful user of outer space. And that's also the essence of this series on space sustainability. So the ASLI, the African Space Leadership Institute, actually derives its motivation from the African Space Policy and Strategy. The idea actually started as far back as around 2016, when we started noticing the idea of having an institute for Africa that could help fill the gap in space policy making, strategy, governance, and leadership as a whole in Africa. And you can see, you see that the idea was even published in the Space Policy Journal. The paper is publicly available for everyone to read. But in terms of practical work or implementation, we actually started, in terms of organization, actually started in 2021, November, and then we were able to get the institute registered in July last year, and then did a public presentation in October last year. So since then, we've kind of been, it's still a relatively new institute, so I won't be surprised if some people may not know about it. So what was really the mission of the institute? And it's just twofold, basically. First of all, to support current space leaders. What do leaders do? They do policy making. So we want to support the efforts of leaders in developing appropriate policies for their organizations, for their countries, for different blocks within the African states, the regional economic blocks. Leaders also make decisions. There's a slight difference between the policy and decision. Policy is a guide, it's like a guiding document or something. So we also want to support leaders in making the best decisions for Africa. We do a lot of international cooperation. We go into a lot of projects. Some of these things, the people do it without any informed knowledge. So the Institute wants to support current leaders in that aspect. And then also in strategy development, both at the national level, some countries have national space strategy. We want to support in developing appropriate strategy for that. And then at the firm level too, private companies too, you will see that many African companies, their kind of sphere of operation is within Africa. You have very few space companies that do international business. And many African companies, they focus more on the downstream. You have very few that are upstream. So, sorry about that. So I was talking about strategy development. So I've talked about the national level, the private sector, that's industry, but even also when it comes to even military too, for defense and national security, they also do strategy. So we are here to also support that. And then governance. When I say governance, it includes law, it includes regulations, it includes even non-binding things like norms. The Institute wants to support African leaders in things that have to do with that also. And then also serve as a think tank, a platform for people to come and discuss issues that affect Africa and how Africa may respond. So different means of supporting current leaders, but also to support future space leaders too. So we plan to have as many courses as possible, anything that education, and then also to expose people too. So that's what we plan for fellowship. So this is just a little of what we plan to do. I just decided to put it in pictorial form so that you see it like a summary in terms of service offerings, capacity building, organized webinars like what we're having now, conferences, training courses, symposia, colloquia. Of course, also do publications too based on research. And this could be published in journals, policy briefs, books, and things like that. Hopefully, we also plan to have a library, both an online library and a physical library, also engage in advocacy and advisory services. So in terms of programs, we've actually just wanted to highlight a few programs we've done. One of the flagship is the Policy Talks, which is kind of like an interview program where we bring leaders, global leaders, to speak about space issues, how they impact on Africa, and how Africa may respond. Just 2 days ago, I had a chat with the Assistant Director for Space Policy in the White House, who more or less serves as the advisor to President Biden on space policy. Next week, Thursday, I'll be speaking with a former chairman of UN CUPUS to speak about Africa's participation in CUPUS, in its subcommittees, and in other space organizations as a whole. So you're welcome to join us then. That will be next week, Thursday. And then the other thing, another flagship program is the Space Policy Roundtable. We've done one. We did one that was in November last year, but that was focused on the US-Africa Space Partnership. As you're aware, in mid-December, there was the US-Africa Leaders Summit. And one of the side events was the US-Africa Space Forum. But before that, we had planned this Space Partnership Roundtable, and we were able to bring experts from both the US and Africa, and ambassadors, like the US ambassador to South Africa gave a keynote address, the African Union Commissioner, they also gave a keynote address. One of our values in the ASLI is accountability, both within the organization, but we also want to encourage African leaders to be accountable to the African people. So when African leaders go for any meeting or conference, we want feedback, we want interaction with the African constituency. So what were the discussions that went on? What was the outcome of the discussions? And the US Africa Space Forum that was held last year, we were able to get to give us a feedback of what happened there in the course of the year. More policy talks, hopefully to be but hopefully we hope that we'll on other platforms. We plan to have more space policy roundtables, but it's coming up on March 8th, and it's focusing on small satellite development in Africa. We already have the panelists who have all agreed to participate in that. So that will come up on March 8th, and the information will be made available. Like I said, we plan to have courses. We already have courses already in place, and the first one coming up is the space policy course, which is going to start in April. The proper announcement for that will be made next week. Everything is set, all the facilitators, and we have facilitators from not just Africa, from all over the world. And maybe I shouldn't talk much about that for now. I wanted to describe the concept behind it, but I think that's not the purpose of this meeting. So courses on space policy, on the African space policy and strategy, on building national space capabilities, generally wherever we see gaps within the African system, we want to see whether we can fill up those gaps. We plan to have webinars. We are starting with lasers in space today. Next month, we're going to be having a webinar on ASAT by Brian Whedon of Secure World Foundation. In March, we are going to be having Professor Ram Jacko to talk, and his team, actually he's coming with his team to talk about the Milamos manual, that's about governance of military activities in space. And then from there, we see where we can go from there. More of the view from the site. A lot of meetings are being planned this year. Corpus S&T meeting is starting 6th of February. Is it 6th or 8th? But next month, and then you have the legal subcommittee meeting. Very importantly, the WRC, which happens once in every 4 years. It's happening this year, and other space meetings are happening. So we hope to get people who are participating to give us a feedback and get input from the other stakeholders. We also plan to have book talks also. We already have one planned for March by Rose Crocia. Rose Crocia, she works with the US Office of Space Commerce, but she's writing a book for developing countries. So it's not just books by Africans, it's books by anywhere in the world, but once you see that it's going to benefit Africa or developing countries, we invite them to talk on their books. So please watch out for the course starting very soon. The announcement should be made next week. So that's a brief about ASLI, and I think anyway, I don't expect any questions for now because the focus is not on ASLI. It's actually focused more on the topic, which is on lasers in space. So without much further ado, I'll just hand over to Peter to go on with his presentation. Thank you.
Thanks, Etim. Hi, everyone. Good morning to all. Thanks. First of all, thanks, Etim, for having me here and inviting me here. It's an honor to be one of the speakers at the African Leadership Institute. And first of all, I wanted to congratulate Etim for launching and leading the institute. I think it's a very great thing for anyone interested in space in Africa, and especially developing the new set of leaders. I think we can all agree here that there's extreme potential and untapped potential in Africa in terms of technology development, use of lasers, and bringing maybe different perspectives to how things and affairs in space should be conducted. So I applaud the team for putting together such a great series of talks and webinars and a group of people to really build the new generation of leaders in space and African leaders in technology in general. So that's just the first thing I wanted to say. Secondly, it's great to have the opportunity to talk about the use of lasers in space. I will try to speak a bit about the use of lasers in space in general, their potentials, the different use cases, and also the risks that are associated with this, as with any other space technology. And then I will be happy to sort of open up for questions and have maybe a more interactive part of the talk. I will share my slides here, and I will just give you a brief intro about myself and my position. I have worked on the use of lasers in the past 4 to 5 years, specifically as a researcher at the Charles University in Prague, and then at the European University Institute in Florence, Italy, and then at the Czech Academy of Sciences at the Laser Institution High Center, where lasers are developed and lasers for space are developed. So this has been both my professional and a hobby of mine in terms of the past 5 years, and that has allowed me to look into very closely what the potential and the risks are. One of the things that we did with my colleague from Charles University is that we put together an initiative called peaceful use of lasers in space. And within this initiative, we put together several signatures of Nobel Prize winners to sort of support development of measures and transparency and confidence building measures to use lasers in space. We have presented a report to the United Nations Disarmament Affairs Office as part of the consultation process on developing norms for responsible behavior in space, which is a process that has been started about 2 years ago and led by the United Kingdom to really sort of unblock the stalemate that has been happening in terms of international space relations, international space law, between, let's say, the West and maybe the bloc represented by China and Russia, as the discussion about how to develop responsible behavior in space is very linked to geopolitics. Clearly, it's linked to different capabilities, different space capabilities, and it's also linked to the fact that it might be easier for those with higher and bigger weapons to develop and define these norms and block others from developing such weapons as well. So it's a very difficult discussion, and lasers in space are very much linked to this. I will share my slide now. So hopefully you can all see the screen, the slide. So my current position right now is I'm a co-owner and strategy manager at the company TRL Space. So it's a company that builds satellites. We develop a laser application as well. So I'll mention that well. But we are a system integrator to build small satellites up to 300 kilograms. We are from the Czech Republic, from Brno. And we are focused mainly on helping developing and new emerging space nations to develop capabilities, provide technology transfers, and develop the knowledge to build satellites, to use benefits of space themselves. And in that sense, we're trying to differ from other companies that are maybe just selling and providing complete solutions. We are always trying to partner with local institutions, with local universities, with local companies, and facilitate a knowledge transfer and build things together as partners, not only as providing and selling things to our clients. So this is something that we differ in. We have a long history about launching several infrastructures into the space since the Czech Republic has joined ESA, and that has helped us also to learn from others, learn from other European companies and countries how to build big satellites and build big complex space structures. And we sort of now, when we have the ability, we want to continue this journey further and help others to learn how to do things in space, essentially. We are operating over the world, so we have different projects across essentially every continent. In Africa, our main focus countries are Rwanda and Kenya, where we are cooperating with local space agencies on different projects. We're facilitating different projects that are focused on helping local institutions and companies to be able to benefit from space, learn things, and we're definitely looking to do more operations on the continent of Africa, as I said. And again, it is a thing that we do because we believe that by building and sharing knowledge and building strong partnerships, that it's a long-term beneficial way to cooperate with others. Essentially, to do things together is always better than to do it separately. Our company vision is check flag on the moon and our product and service on every continent. One of the flagship projects we do is a lunar mission. I'll just mention that briefly before I get to lasers. These are just some numbers about our company and the numbers about our big team. We are still an SME, so under 50 people. We're building 3 satellites, 1 moon probe, different products, including laser. And this is the laser system we're building. It is a small laser that will be able to detect objects on the orbit and provide very high precision and accuracy space traffic management and object detection, which is one of the uses of laser that I will get to later. And just quickly, LUGO mission is our lunar mission to explore lava caves and lava tubes on the moon. It is a mission that is international. We are leading it. There are 30 different scientific and industrial institutions, many different scientists from Europe, from the US, from South Korea. So this is a very big international mission to explore lava tubes on the moon. That would be, of course, another great, exciting talk to talk about lava tubes, but that's maybe for a different time. Troll, that's our own satellite that we're building from our own internal investment that will be flying next year, and it will be a first test of our laser system for ensuring sustainability of low Earth orbit. So now I will talk about the use of lasers in space. There are different uses of lasers, and the beneficial ones. I will not cover all of them, but in general, the main ones are in 2 or 3 categories. One is for space traffic management. Another one is for, let's say, space exploration. Another one is for space or planetary defense. And these 3 categories, I think, sufficiently cover the overall potential that there lays in laser technology. And I will start with space traffic management as the most, let's say, eminent benefit that there lays here. On the right-hand corner, up corner, you can see just a map of all the objects around the planet, all the satellites. You might know that we have a rapidly increasing population of satellites on low Earth orbit, as well as on the geostationary orbit. And we are essentially trashing the proximity of Earth with satellites, but also debris, inactive debris, and it is causing big problems. It's important to understand what type of a problem, because the orbit of Earth is vast enough to accommodate millions of satellites, but it's not so easy to accommodate them safely. We need traffic management for that. In 2018, I think we crossed the number of satellites on Earth orbits at 2,000 pieces. Right now, there's over 5,000 satellites. And by the end of this decade, we should have over 100,000 satellites. So that's a very exponentially, growing number. And the risk there is not that the objects might not be able to be, to fit there. The risk is that we do not have the means and the capabilities to ensure that these satellites do not crash into each other, that they do not cause more that they do not cause more debris that could cause potential other collisions. So essentially that we do not have the means to ensure that we avoid the Kessler syndrome, which means that there will be a chain reaction of collisions, each of them creating more debris, which would create more satellite crashes and creation of more debris, and essentially laddering Earth's orbit and preventing placing of another satellites or even launching rockets. That is the apocalyptic scenario here, really. The problem there is that we do not have sufficient information about the precise location of all the objects. That's problem number one. So we don't know where exactly the satellites are. We know we're tracking them. We're tracking all of them. We're tracking also small pieces of debris, but there is a big imprecision there. So with the ground instruments that we're mapping this with, which include radars and telescopes and even laser systems on ground, we map them, but we have a big uncertainty. And if there's a small satellite, we have to count with the possibility of the satellite being within 1 kilometer of range. So it means that our measuring is so inefficient that we have to count as if every satellite was 1 kilometer wide, because that's just the probability with which we can estimate if it's going to crash into another one. The benefit of laser here is both of ground-based and space-based lasers is that it has a high precision rate and high accuracy rate. So we would essentially eliminate this problem. What this problem with not having precise data causes is that satellite operators and space traffic managers have to deal with hundreds and thousands of collision warnings. But these collision warnings are false because we do not have precise data. So the problem here is really capacity of space traffic management to ensure safe functioning of the satellites. Lasers, and especially space-based lasers, would be a solution to provide very high accuracy information about all of these objects on space. Another part of this problem is that we are not able to track and detect small pieces of debris, small as in below 2 centimeters. And even a centimeter piece of metal that has been chipped off of another satellite can cause a whole misfunction and malfunction of the entire satellite. It can destroy it. It can destroy its panel. It can destroy its payload, and it can essentially be fatal and lead to more collisions. And we are not able to track those. And laser technology and the LiDAR instruments, for example, the one that we're developing, is a solution for that. So that is one area which is space traffic management. Another area is that you can consider is prospecting and space exploration. On the right bottom corner, you can see a map of the moon. You might have heard about uses of resources on the moon and in space, especially on the moon. That is the most imminent area where we will use resources and build things from them on the moon. The problem there is that moon is very essentially very big, and prospecting where different resources, minerals are with a rover that moves very, very slowly is just not a sufficient way to explore those. Lasers can help in different types of ways. They can be used as some laser retro reflectors to shine on a surface that is in shadow, and by the reflected spectra, we can detect and estimate what mineralogy there is. And we can also use laser-induced breakdown spectroscopy, which can tell us the composition of different materials. That use of technology is relevant, maybe not for prospecting, but for analyzing the materials as we process them throughout the whole production line. So that is another very important use of lasers in space. And the last one, well, I'll stay with the space exploration because I didn't mention one. You can see this very popular video of SpaceX landing, those two rockets, two boosters at the same. That's definitely the most exciting, let's say, technology maturation in terms of rocket engines, but we are still just burning fossil fuel, and it is not a very efficient way of getting up there and traveling in space. Laser technology has been researched and developed to be used for interstellar travel. So I will show this slide later as well. But for speeding up spacecraft to 20% of speed of light. It is a concept by Breakthrough Initiatives called Breakthrough Starshot. I will get to that later, but lasers can also offer a much more efficient and green way of space travel. And just quickly, the last part I will mention is the near-Earth objects. On the left side here, you can see the population of near-Earth objects as it has developed, as we discovered more and more asteroids orbiting not just only in the solar system, but also around Earth. So there is hundreds of thousands asteroids that we have detected in our solar system. And there's over 20,000 potentially hazardous asteroids that are orbiting Earth and could at some point be risky for us. Lasers have different uses for this. They can be used also for detecting asteroids that are coming from the sun. So the problem with that is that the only way we can see an asteroid is that it reflects sunlight. If it's coming from side of the sun, we obviously don't see it because we're looking right into the sun and there is no sun to be reflected from the asteroid. We could use lasers to shine on some of those asteroids and track them as we do with satellites with LiDAR. There's another way to use a laser to ablate parts of a potentially hazardous asteroid to move it from the impact trajectory. And we can also just use lasers to prospect such an asteroid, either for potential mining or for just understanding its composition and understanding the way how we need to deflect it. So these are just short descriptions. The existence technology.
Sorry, Peter?
Yeah.
So the previous slide, sorry. There's a quick question. Someone is asking in the previous slide whether the red spots are space debris.
Sorry, say it again. I'll just open it up.
Yeah, there's a question about the red spots.
Yeah.
I guess on the image on the upper right, are those space debris?
That's a good question. So this is a geostationary orbit. So I don't think this is where the red spots are. I don't think that's debris. I would rather think, sorry, I don't have the legend for the picture. I think those are, bigger satellites. So geostationary orbit usually has bigger satellites. So I think that differentiates the size of the satellite rather than that signals a debris.
Yes, thank you.
Great. So just to quickly talk about the existing laser technology that is used for tracking debris. These are pictures of laser ranging facilities. On the left up corner, it's one is in Australia. They have developed ability to deorbit space debris with lasers. They are doing it in a way that they detect a piece of debris, and as it's coming over the horizon, they shine light on it. The light is very intensive, and it essentially transfers kinetic energy. So the amount of photons that is pushing on the piece of debris is so big that it transfers kinetic energy and it slows the debris down in its orbit. When you slow the piece of debris down, it means that it starts entering lower orbits. And if you lower it up to the 200-kilometer altitude, then it enters into an automatic, orbit where it's getting tracked by Earth's gravity and burns in the atmosphere. So that is one way they have developed a way to destroy space debris with lasers. And the picture on the right bottom corner is from Austrian Academy of Sciences. They have a laser ranging station where they have developed a very unique ability to track pieces of debris and of satellites even during daylight. So usually this technology or this technique has been only possible to do during nighttime, where you do not have so many photons and so much light, because you're really just detecting every single photon reflected from your satellite that you're shining a laser on. But they were able to do this also during daylight. So that is a very exciting advancement in using lasers for tracking pieces of satellites. Another activity in laser development that is happening is developing space-based lasers for detecting and also moving either satellites or pieces of debris. On the left down corner, that is a concept by Claude Phipps, laser researcher that has been developing lasers in space for a long time. And it just shows how the system would work. So there are essentially two ways you could move debris and satellites in space by lasers. One is the same principle I described for ground stations. That means you exert a high amount of photon pressure and transfer kinetic energy to do so. But that's only applicable for pieces of debris. You wouldn't be able to do it for a satellite. But for a satellite, you can do it by ablating it, by essentially burning it. And the ablation, fires the material out of the spot, which serves as a sort of a jet that moves it. So the picture on the right, that's a concept developed in Japan, also to develop a space-based laser that would be able to ablate and move satellites. I have shortly mentioned the use of lasers for ablating them and measuring the spectra to understanding what they're made of. So there have been also different concepts developed to use this to move asteroids just as you would move a satellite. Obviously, that requires a lot of energy, which is very hard to get up there in space. This is an interesting simulation of, let's say, a rotating piece of meteorite this time, and using it to, burning it, and using the photon pressure to, change its rotation. So, just a quick note, even just changing the rotation of an asteroid would be sufficient to change its trajectory and potentially its impact on Earth. This is something that has been done by the DART mission by NASA last year, that has recently crashed a satellite and kinetic impactor into an asteroid to lower its spinning, and that has led to change in its trajectory, and which was the first try that humanity has ever done to deflect an asteroid and potentially use this technology for an asteroid that would be threatening Earth. This would be just a different way to doing it with lasers instead. So this is the concept that I talked about, the breakthrough starshot, of using a laser array. So essentially millions of small lasers organized in these hexapons that would generate such a big photon pressure on small chipset satellites that would accelerate them to the 20% of speed of light. If you look on YouTube, there's a National Geographic show that has a great description of this whole process and technology, with great graphics that really explains what this is all about. This is a concept that aims to explore the closest star, Proxima Centauri, because there are there's a very interesting exoplanet circling one of these stars in the star system. It's 4.2 light years away. If you've seen Avatar, Avatar's planet Pandora is based on this exoplanet, and that is a very good candidate for a planet that might have liquid water and could potentially host life. And it's the closest one. So this concept is based on reaching that star within our lifetime, within 20 years, and then send the information about it back again with laser communication. It's obviously very difficult to develop. Breakthrough Starshot is an initiative founded by Breakthrough Initiatives. It is a international research to develop this type of technology. And clearly it's very costly, very difficult to do, but there has been a great success in some initial studies on how this could be done. So I encourage you to look online and search for this great visualization, because that is I think the closest we get to traveling to different stars. It is theoretically feasible, and we're moving forward in develop the technology, and I believe that this is a way for humanity to travel to or explore distant places in the galaxies. So these are great, obviously, uses of lasers in space. They have a great potential for humanity, for humankind, to advance our flourishing, to make our lives better, to make sure that we survive in terms of planetary defense, to make sure we use space sustainably in terms of space traffic management, and to enable humanity to become multiplanetary species through space mining, and also to explore other star systems by laser travel. But obviously, the picture is not as easy and optimistic as this is. It has a lot of challenges, and the biggest challenge is in the dual use nature of laser technology. So you can imagine, if you can do all these amazing things with lasers, you can do a lot of malicious things with lasers as well. And this picture here, that's one of the interesting examples that I think describes the dual use and dual nature of lasers. That is a laser system called Polius, and it was developed in the Soviet Union in the 80s. During the 80s and also during the 70s, when the US had the space shuttle system, it was very, very costly. And for the Soviets, they couldn't believe that the US is spending so much money to launch things up there in space. So they just believe that there has to be something more behind it, that the space shuttle is not there just for doing science and building space stations, and they believe there was clear hidden military goals. And they were convinced that the US is building space-based lasers to use and attack Soviet Union, and to even be able to decapitate individual people from the orbit, which was not true, clearly. But this has led them to develop their own big space-based laser that would be able to shoot down on Earth and really, in kind of a sci-fi format, just shoot down from orbit to Earth. So they developed this carbon dioxide laser called Polius. That is the black side on the rocket. The rocket, that's the Energia rocket, the booster that the Soviets have developed for their Buran space shuttle. So very much like the system that was carrying up the space shuttle. They placed this laser up there and they launched it in the 80s. However, the laser system malfunctioned, and it never worked. And it was never made operational. So that is the positive thing, and this is where the story turns better, is that soon after that the Soviet Union collapsed, and at the beginning of the 90s, the US and Russia started the International Space Station project, and obviously there was a lot of a military space equipment, just like a service module from this Polius laser, and the service module from this laser system was actually then used as a contribution from Russia to the International Space Station, and provided services and electric power systems and communications and so on. So you can see a clear example how development of such a big military laser has actually led to something beneficial when the rivalry was taken away from it. But I think this points us to the fact that lasers have many challenges, many risks, as many as they have benefits. And as a humanity, we do not have global governance systems and mechanisms that ensures that all technologies used for benefits of humanity, even though space is declared to be used only for benefits of humanity and all countries, as it says in Outer Space Treaty. But we all know that humanity is not following this closely, to put it mildly, and many challenges are associated with misusing lasers in space. So what this means is that there are known dual-use laser weapons that are, on that borderline of of being developed for civilian applications, but then being misused for military applications. There's a great literature about these two Russian systems. The one on the right is a Perservet, which is a mobile laser ranging system that Russia has on truck and also on aircrafts, and it can be used to blind satellites and their optical sensors as they pass over certain areas. And on the left, that is a station. It's really fascinating. I give you links at the end of the presentation about great investigative work on these systems. There are public information about every single detail of these two systems. On the left, it's the Kalina system, which is again ground-based laser ranging station, just a malign civilian station, but which has been upgraded with a specific intent to use it for damaging and blinding satellites that pass over Russia. So that is the first example. There are many other examples, as I said. Even the weakest satellite that is used for laser ranging on the ground station can be used to blind a satellite, optical sensor of a satellite. It can be used to permanently damage it. And we know that this is already being counted on in all these different observation strategies, that we know where some ground-based laser ranging stations are, and satellite operators, military satellite operators have to count with the possibility of being, attacked by such a ground-based lasers. And this has been mentioned by, for example, the U.S. military, that the Chinese are using this frequently to blind U.S. satellites. And it raises so many different questions also that lay at the core of misuses of lasers in space, but also misuses of any technology in space. So first, there's the risk of the dual-use nature. Even if a technology or a space-based laser is designed for civilian uses, it can be, misused for the malicious and, military or even offensive uses. So it's very easy to misguide and hide the original intent of use, as the example with the Russian Kalina system, for example, or any other. Secondly, it's very hard to detect the damage done by a specific laser. So it's similar to cyber attacks, essentially. We can see if there is an attack by ground-based laser ranging station, if it's done over an area where the station is. We can approximate that this was the station that fired. But if this happens from a space-based laser, they can be much harder and can be even hard to even detect that a malfunction on a satellite has been caused by a laser or energy weapon. It can be such a small impact on the satellite that it can be even hard to be noticed. And thirdly, there's a difference between temporary and permanent effect of the laser that on a satellite. So it can just blind a satellite's sensor in sense that it just shines light on it, and then the satellite cannot maybe take a picture, for example, of a military station that a country is trying to protect. So that could be maybe understood as a temporary effect. Sorry about that. In a self-defense effect. But if that laser damages the optical sensor, is that considered an offensive attack on another nation's satellite? Is that still self-defense? If it's coming from one country's territory, but reaching into space, which is no one's territory, and attacking satellite of another country's territory, can that be considered self-defense, or is that attack already? And what is the intent? Was the intent really maybe just to track a satellite, or was the intent really to attack? That can be very easily, hidden and hard to distinguish. So these are risks associated with any other use of technology in space. And one of the, considered ways how to lower the risk of misuse and potential incidents is to have verification, transparency, and confidence building measures. They are considered the main tools of arms control.
Yeah, you can go on. You can unmute.
Yeah, sorry about that. I muted myself and I cannot unmute. So, go to the next slide. Yeah. So, there's different mechanisms that have been developed to share information about use of laser in space. One of them is instituted in the United States. It's called Laser Clearinghouse. And it's a mechanism and a system that ensures that everyone who wants to use a laser for tracking purposes from ground has to go through the paperwork and ensure that it is not hitting any satellite. So in the US, there is a system already that makes sure that use of laser doesn't damage satellites passing over, but it doesn't address use of lasers from space-based in space, right? From space. It is a system that has been proposed by the US to the Russians in the 90s to develop an international laser clearinghouse, but for many reasons it has been scrapped because essentially it would allow the countries to understand where their satellites, their important satellites, are passing over, which is something that the countries wanted to, in the end, avoid. There's another institution called International Laser Ranging Service, and it is a institution that puts together, I think, about 70 ground-based laser ranging stations from China, from Russia, from Africa. There is one in Egypt, from the US. And it allows them to share plans about satellite laser ranging. And it also allows a satellite operator to request a satellite ranging service from them. So there are these platforms, but they're obviously not sufficient. They do not extend to use of lasers in space by space-based lasers. And they do not provide, sufficient measurements, or, they're not used by all the actors to provide sufficient verification, transparency, and confidence building measures. But that is one of the, easiest way how this could be addressed. But Obviously, there's a long way to go for all the actors to use these system platforms and to share information about their intent and plans to use lasers in space. So I'm nearing the end of my talk. I wanted to share this slide with you on a bunch of interesting reads. I have written several different articles and research articles on the use of laser in space, its challenges, its norms, ways of governments. But also, if you want to read more about those mobile laser systems or ground-based laser systems that have been greatly uncovered by investigators, those are the two links on the top that you can see and look at. They're very fascinating reads. But I guess this will be all from my side. I hope this was interesting, and I'll be happy to maybe answer some questions if you have. Thank you.
Yeah, thank you very much, Peter. That was quite fascinating, going through the technical background first, and then talking about the risk. So I've not seen any question on the chat box. Is anybody that has a question? Maybe I can start. When you were talking, you talked about the the laser weapon that was developed by the Russians when the space shuttle was being used. And of course, like you mentioned, this was due to a misconception about the purpose of the space shuttle. So I don't know, can we tie that down with the issue of, the need for transparency and confidence building measures? Because perhaps if the US was a bit more transparent, in quote, with what the purpose of the space shuttle and the future missions that were coming up the ISS, maybe those misconceptions will not have been there. What do you think?
No, that is a good question, Etim. So from my understanding, the Russians essentially could not believe that the US would spend money so inefficiently on a space shuttle. And that, that is an objective criticism of that has been around at NASA, that the space shuttle was extremely expensive, that it was, mismanaged, that way too much money and inefficiently were spent. I think the, Challenger disaster are examples of problems of this whole program. However fascinating that program was, it had a lot of problems, especially in terms of using resources efficiently. So I think that is the real problem. The Russians, they just couldn't understand and believe that the US in, the capitalist system would run something so inefficiently in maybe even in a way that would remind them of a centrally planned economy, right? So they just couldn't believe it, and they weren't convinced that there isn't something behind. So I rather understand it was not an issue of transparency, but the issue of, the Soviets not believing that the Americans can spend money so badly.
Okay, maybe a follow-up question to that. Thanks for your response. And the follow-up question was shortly after that the former Soviet Union disintegrated, and then Russia came up, and President Bill Clinton was actually invited Russia to join the Space Station Freedom Project, which now became the ISS. And that brings, the question or a concept about maybe by including Russia in that giant international project, that also eliminated some misconceptions, and also that also opened up maybe a little bit of the Russian space program to global attention or scrutiny. So what do you think about more inclusive space exploration? I mean, a lot of projects are coming up, a lot of programs are coming up. So if you include more people, let's take, for example, the moon missions that are going on now, it appears to be two different groups of people. those on the US-led Artemis program, and then those on the China, Russia. But if you find a way to make this more inclusive, it appears the misconceptions and the fears could maybe eliminated. What do you think about that?
That is a great question, and there's a big debate within the international relations and political science literature about the effect of space cooperation on international relations, right? And there is a big field of theory that is called large technical complexes. And that theory says that if you bound even rival nations into cooperating on a big technology complex, like the International Space Station, or like the CERN, the Large Collider in CERN, then you will lock them in technical and scientific cooperation that will that will pass over the national interests and rivalries that are inherently ingrained between those nations, and that it will lead to more cooperation in other areas and lowering the tensions. However, when we see the International Space Station has not lowered tension between the US or Russia, it has, it's on the very, very much opposite of that, especially now. So now the debate is a little bit changing, because there's an interesting thing. Even though there is essentially a war going on between the West and Russia, the cooperation on the International Space Station has not been severed. And there's an interesting story about 2014, when the first Russian invasion to Ukraine happened. Then the Western sanction when launched, Vladimir Putin wanted to, separate the Russian part of the International Space Station from the rest of the space station. But the scientists told him that, they can't do that, that it's impossible, that it wouldn't be the right thing to do. So, there are some limits on both sides. Cooperating on space projects doesn't necessarily mean you will not enter war, but at the same time, it does at least mean you will not separate the cooperation completely on something that you're already doing up there in space. So I think that is a takeaway. But at the same time, we clearly see that the world is entering, especially in terms of moon, another geopolitical rivalry between the West and Russian-Chinese plans to explore moon and build stations. So I think that's the new reality. And there's, I don't see much, light coming out there from that part, because we're entering a new, series of geopolitical rivalry where these things will just happen separately, and maybe in future we can think about some Western Chinese space cooperation, but I think it's completely off the table at this point.
Okay, thank you. I see a hand raised, but before I call on Promise, let me quickly read out some questions in the chat box. So there's a question on what do you think is the most dangerous use of the lasers? So
obviously on Earth, there's a lot of the uses of lasers. In space, I think it's the blinding and just damaging the laser. For example, you can use the laser to heat up a satellite's battery to the point that it explodes. That is a potential use. You can damage solar panels of a satellite. You can burn the silicon semiconductors on the chip of a satellite. So essentially, lasers can be used to completely destroy a satellite, and then the satellite becomes a debris, and that's the danger. So the biggest danger is that you create something that becomes a threat for everyone else, even yourself.
So maybe I just follow up with a question to that, and that is it possible for someone to use a laser to impact on a satellite to destroy it? And you
So I think we have lost Etim. So maybe I'll just take the question in chat before he comes back. So the question by Brian: given the fact that lasers present potential danger to satellites in space, what mechanisms of remedies can be deployed to minimize or counteract such danger? So for example, for optical sensors, there are different coatings that are used to protect laser light from a different angle to use, or for light at a certain intensity to enter the optical sensor. Then you can use different, hardening of the satellite parts that could be used as well. But since this has not been, widespread use of lasers to use them for burning satellites, essentially, I don't think any satellites is protected against that. What is another threat by lasers is that it can be used to disrupt laser communications by sending, false photons. So that is also, a potential threat. But for optical sensors, different coatings, that's one of the, remedies that is being used.
Yeah, thank you. Sorry, I think I was out for some time. I don't know what happened. Yeah, I was talking about comparing laser attack with cyber attack. There's this problem of attribution when it comes to cyber. Do we face such similar problem in space? If you use a laser to attack another country's satellite infrastructure, is it a problem of attribution, or can you identify where the attack came from and maybe which country attacked with a laser?
You can identify if it's from a defined ground station that has laser systems. You can maybe do it if there's a satellite with a laser that is approaching your own satellite, but that requires you to know that there is a powerful laser on that satellite, and that it's not that easy to know, right? So the laser doesn't really have to be something large. It can be well, hidden. It can be not acknowledged that there is such a thing. So that is the danger of attribution. There is the challenge of attribution. If there is a satellite with a laser that no one knows that it has a laser, and then it just hiddenly attacks different satellites in its proximity. It doesn't have to be that proximate. It can be tens or maybe hundreds kilometers. So it can be hard to do that because the pulse of the laser is too fast to be detected, really, unless you're watching there on the specific wavelength. So that is the challenge of the attribution. Just really, you would have to, as you would say, you would have to see the gun smoking to be able to see it. You would have to be with the adequate systems monitoring at the adequate wavelength the laser pulse that was emitted by a specific satellite. So that's the challenge. So there's an unanswered question. I will look for it.
about planetary protection, if somebody is interested in a project on that. Did you see it?
Yeah, I see. I'm trying to think. So okay, so planetary defense. So that is an activity, I have to say, unfortunately, that is reserved or not reserved, that is taken up by NASA, by ESA, more and more by even the Chinese National Aerospace Aerospace Federation. But so it's an entity that is funded by these big space institutions. So that's why it's maybe hard to get into in general. In terms of using lasers, there's a team around Max Vasily in the UK, in the University of Strathclyde, that they have been working on this for quite some time. They have developed several concepts for this use of lasers for planetary defense. There's, as I said, Claude Phipps and Phil Lubin. Those are other two researchers from the US that have focused on this very specifically. So reaching out to them and understanding, what their research plans in this regard are would be a first thing that comes to my mind. But I don't think there are any, open research calls or programs that you can just sign up for if you want to, explore the use of lasers for planetary defense. And I would also say that for planetary defense, the use case is not as big as for other areas, for communication, space traffic management, resource utilization. For planetary defense, it is just one of the, auxiliary technologies, I would say.
So I've just shared on the group, on the chat, the submission of Peter to the UNODA, that's United Nations Office for Disarmament Affairs. It's a very good read. I think it will also solidify what he has shared. Yeah, we have promised. You want to come up with your question? Promise. Okay, Zia. Yeah, you're muted. You can unmute yourself.
Okay, sorry. So my question is, while he was giving the lecture, he mentioned an international laser ranging service. I don't know whether I got that name correctly, but what I understood that to mean is that it was a form of setup that provide space service information. So my question is, to the best of his knowledge, does he know whether there's any form of check or mechanism that specifies that such information provided by such companies that provide space services and render informations in which countries act on? Is there any law, any check, any regulation that specifies that such information must be correct? And if not correct, what is the basis of the liability that may arise?
Yes, thanks. That is a good question. So this is a problem connected to the overall use of space, because space is obviously not only a civilian, but also a military domain. It has always been. And although we have a United Nations registry of objects in space, that countries are registering all their satellites, and that we have different, catalogs of satellites and registries, and even though we have an international telecommunications union where you need to apply for frequency registry and describe that satellite that you're launching, countries do protect information about specifics of their satellites, about what is on board. Not only countries for military purposes, but also some companies do this, obviously, for some, let's say, research or business reasons. So there is not any such registry, any such obligation, nor any penalty to punish people and entities that do not share information about their satellites. So there is, could consider this one of the gaps in international space regulation and space law. Who really will need such information is a launch provider. So launch providers usually ask for a lot of these questions about the content and technology on board. But then again, if it's a military contractor, if they really do not want to share this information, they will not, and there's no one that will make them to do so.
So, yeah, any other question? Okay, if there's not a question, I think I'll just use the opportunity to ask maybe one final question, and that has to do with so many countries are now developing, establishing space command, space force, and all those things. In particular, France has put up such a body. Well, not only has France established a space command, but actually stated clearly that they are going to, on their satellites, they are going to fortify it, they are going to put weapons, including laser weapons, on their satellites. I mean, it was a public statement. There was no comment from the international community. So I don't know, are there things for us to be worried about?
Some countries are saying it openly. Some countries are developing. Japan has stated these plans. South Korea has also stated such plans. I think it is well to be believed that the US possesses such instruments, and the same goes for mobile ground-based satellite laser ranging weapons. So we are entering into a field where there are different types of technologies in space, different types of weapons that are already possessed by some countries, and that is the reality. The international community, I think, unfortunately, will not react to such statements unless they become a problem or unless there is an incident. And it's a similar thing with space debris and with anti-satellite tests. With anti-satellite tests, it has only now become a very big push by different countries to ban these tests. But that is only after we had several anti-satellite tests in recent years that really made and became a threat to international space stations, to other satellites. So unfortunately, I would have to say that this is how humanity works. We do not really, something doesn't become an issue unless it really starts affecting, people and becomes a real threat to them. And maybe, something that would be more precise to say, unless it becomes a threat to the satellites, of Western countries, really, let's be honest here. So I think that's the problem there. If someone else made this claim, if China made a claim about building a space-based laser weapon, I think, the reaction would be much different.
Okay, it appears there's no further question. I was trying to get, okay, I think this will be the last question. Regarding very small space debris, what mechanism is in place to detect them?
Yeah, so there are different, in the US, they have commercialized this service essentially. So companies are like Leo Labs are providing this as a service to the government, to the United States Space Force, for example, and they are able to detect objects up to 2 centimeters. Below 2 centimeters, no one is detecting these objects. We don't know. There might be some that are detectable. There is believed to be, I think, 128 million pieces of 1 centimeter or lower on low Earth orbit. 128 millions. And that was, I think those are data from about 2 years ago, before some of the anti-satellite tests that have been carried out. So the answer is no one.
Thank you. And then I think that's the comment that says the OST largely criminalizes nuclear weapons and or weapons of mass destruction. There's really no talk about lasers in the OST. And maybe that also, there's also this issue of should we open up the OST to renegotiate it or not, but I think that's not the discussion. Anyway, thanks so much, Peter, for the presentation. And I mean, I believe it's been very useful, and I know people will always refer back to this webinar as the in future.
Thanks, Atim. Thanks, everyone, for the attention. Have a good day.
Yeah, have a good day. Yeah, thank you. Bye.